Hello, friends. Today we are getting a lay of the AI land. Think of this as AI for the cartographer. I am Dr. Sonali Tamankar, and we are peeling back the layers in our AI A to Z course. D is for deep learning. My background is in physics, and the famous physicist Richard Feynman has this story. Out on a stroll, his dad pointed a bird out to him and said, "See that bird? It's a brown throated thrush, but in Germany it's called a Halsenfugel, and in China it's called a Changling." Now, there are many versions of this story with all kinds of names, but even if you knew all the real names for it, you'll still know nothing about the real bird. You only know something about the people and their languages. You don't know that the thrush sings, it teaches its young to fly, and nobody really knows how it navigates so well. So we'll dip our toes in some AI jargon today, what the bird is called. We have these circles: artificial intelligence, machine learning, deep learning, generative AI. You'll notice that I've drawn these fractal-like boundaries. This reminds us not to get too fixated on the names because the definitions often blur. They're not even really nested. Monte Carlo methods are an example of generative AI that doesn't really respect this hierarchy. But generally speaking, the big umbrella term is AI, and it can refer to anything from the most rudimentary expert systems to robotics and more. Inside it sits machine learning, where we give data to the computer so that it can learn patterns. Inside that is deep learning. And finally, we have generative AI, where the machine creates new content. Okay, so now let's think in terms of what the bird does, so to say. Imagine we want to know the risk of diabetic retinopathy for diabetes patients. Let's take a walk through history to understand different approaches. Okay, so first we have rule-based era. Think of this as the calculator. Here, the doctors had mental models based on thousands of patients they saw, and the machines just encoded these rules. Like if A1C is greater than 8.5, the risk is high. Then came machine learning. This is the learner. So we stopped giving rules. We gave computer data on thousands of patients and said, "Hey, machine, you figure it out." In deep learning, which consists of neural networks that we'll talk about today, that comes next, the perceiver. Here we could even take the image of a retina and the model can figure out if the patient has retinopathy. The FDA has already approved systems that can screen patients for diabetic retinopathy. In fact, research shows that models can learn something about the age and biological sex of the patient and markers for their cardiovascular risk from these scans, something humans can't do very well. Then we have generative AI, the creator. So now we can ask AI to summarize the latest research articles on diabetic retinopathy. And we are entering the era called Agentic AI. So this is the doer. So this is where an AI agent might track continuous glucose monitor data and automatically book your doctor's appointment if needed, taking your availability and preference into account and negotiating with the doctor's booking agent. Increasingly, this is going to be our reality. I'm pretty sure that in our 2027 AI A to Z course, we are going to have A is for Agentic AI. Finally, a hypothetical future state is where we have human level AGI or artificial general intelligence, maybe even an artificial super intelligence, ASI. Coming back to Earth though, let's now get into how deep learning or our perceiver actually works and why do we call it neural networks. Okay, so this goes back to the Nobel Prize winning work by Hubel and Wiesel. So there's a reference in the description below. They found that a cat's visual cortex builds understanding in hierarchical layers, starting with cells that detect straight edges and building up to those that perceive more complex patterns. So deep learning is AI that is inspired by this biology, There are also differences between how real brain works versus AI, and I'll link an article on this topic below as well. So, in deep learning, called convolutional neural networks, what we have is we have first layers that will detect straight edges, and then the next layers detect curves, and then the deeper layers will detect more complex features like eyes or whiskers. And then the final layer will shout cat. If you remember the dogs versus wolves from our B's for bias video, that classifier used CNNs. Note that we don't tell the layers what to look for. They learn it themselves. This makes them powerful but also opaque because they can accidentally then learn on the snow in the background, right? As its feature, as we saw. So if this opacity worries you, stay tuned for the letter X for explainable AI. So here are our takeaways for D. Most important, your lived and domain experience matters. Forget the jargon. Always think about what does the bird do. And then we talked today about AI as the broad umbrella term, and within it, deep learning refers to neural networks with these many layers. And these layers act like the visual cortex, learning the hierarchical representations and finding sophisticated patterns in data. So that's it for today. See you tomorrow with E is for embeddings, and that will build up to F is for foundation models, and then G is for GPT. So bye for now and have a great day.